Item 342. Permeable friction course. 1. Description. Construct a hot mix asphalt, HMA, surface course composed of a compacted permeable mixture of aggregate, asphalt binder, and additives mixed hot in a mixing plant. 2. Materials. Furnish uncontaminated materials of uniform quality that meet the requirements of the plans and specifications. Notify the engineer of all material sources and before changing any material source or formulation. The engineer will verify that the specification requirements are met when the contractor makes a source or formulation change, and may require a new laboratory mixture design, trial batch, or both. The engineer may sample and test project materials at any time during the project to verify specification compliance in accordance with Item 6, Control of Materials. 2.1 Aggregate. Furnish aggregates from sources that conform to the requirements shown in Table 1 and as specified in this section. Aggregate requirements in this section, including those shown in Table 1, may be modified or eliminated when shown on the plans. Additional aggregate requirements may be specified when shown on the plans. Provide aggregate stockpiles that meet the definitions in this section for coarse aggregate. Do not use intermediate or fine aggregate in permeable friction course, PFC, mixtures. Aggregate from reclaimed asphalt pavement, RAP, is not required to meet Table 1 requirements unless otherwise shown on the plans. Supply aggregates that meet the definitions in Tex 100E for crushed gravel or crushed stone. The engineer will designate the plant or the quarry as the sampling location. Provide samples from materials produced for the project. The engineer will establish the surface aggregate classification, SAC, and perform Los Angeles abrasion, magnesium sulfate soundness, and microdevol tests. Perform all other aggregate quality tests listed in Table 1. Document all test results on the mixture design report. The engineer may perform tests on independent or split samples to verify contractor test results. Stockpile aggregates for each source and type separately. Determine aggregate gradations for mixture design and production testing based on the washed sieve analysis given in Text 200F, Part 2. 2.1.1 Coarse aggregate. Coarse aggregate stockpiles must have no more than 20% material passing the number 8 sieve. Aggregates from sources listed in the department's Bituminous Rated Source Quality Catalog, BRSQC, are pre-approved for use. Use only the rated values for hot mix listed in the BRSQC. Rated values for surface treatment, ST, do not apply to coarse aggregate sources used in hot mix asphalt. For sources not listed on the department's BRSQC, build an individual stockpile for each material. Request the department test the stockpile for specification compliance, and, once approved, do not add material to the stockpile unless otherwise approved. Provide aggregate from non-listed sources only when tested by the engineer and approved before use. Allow 30 calendar days for the engineer to sample, test, and report results for non-listed sources. Provide coarse aggregate with at least the minimum SAC shown on the plans. SAC requirements only apply to aggregates used on the surface of travel lanes. SAC requirements apply to aggregates used on surfaces other than travel lanes when shown on the plans. The SAC for sources on the department's Aggregate Quality Monitoring Program, AQMP, Tex 499A, is listed in the BRSQC. 2.1.1.1 Blending Class A and Class B aggregates. Class B aggregate meeting all other requirements in table may first be blended with a Class A aggregate to meet requirements for Class A materials. However, Class B virgin, non-recycled, aggregate may be disallowed when shown on the plans. Ensure that at least 50% by weight, or volume if required, of the material retained on the number 4 sieve comes from the Class A aggregate source when blending Class A and B aggregates to meet a Class A requirement. Blend by volume if the bulk specific gravities of the Class A and B aggregates differ by more than 0.300. Coarse aggregate from RAP and recycled asphalt shingles, RAS, will be considered as Class B aggregate for blending purposes. The engineer may perform tests at any time during production, when the contractor blends Class A and B aggregates to meet a Class A requirement, to ensure that at least 50% by weight, or volume if required, of the material retained on the number 4 sieve comes from the Class A aggregate source. The engineer will use the department's mix design template, when electing to verify conformance, to calculate the percent of Class A aggregate retained on the number 4 sieve by inputting the bin percentages shown from readouts in the control room at the time of production and stockpile gradations measured at the time of production. The engineer may determine the gradations based on either washed or dry sieve analysis from samples obtained from individual aggregate cold feed bins or aggregate stockpiles. The engineer may perform spot checks using the gradations supplied by the contractor on the mixture design report as an input for the template. However, a failing spot check will require confirmation with the stockpile gradation determined by the engineer. 2.1.1.2 Microdeval abrasion. The engineer will perform a minimum of 1 microdeval abrasion test in accordance with TEX 461A for each coarse aggregate source used in the mixture design that has a rated source soundness magnesium, RSSM, loss value greater than 15 as listed in the BRSQC. The engineer will perform testing before the start of production and may perform additional testing at any time during production. The engineer may obtain the coarse aggregate samples from each coarse aggregate source or may require the contractor to obtain the samples. The engineer may waive all microdeval testing based on a satisfactory test history of the same aggregate source. The engineer will estimate the magnesium sulfate soundness loss for each coarse aggregate source, when tested, using the following formula. TxDOT equals RSSM times MDACT over RSMD, where TxDOT equals magnesium sulfate soundness loss. MDACT equals actual microdeval percent loss. RSMD equals rated source microdeval. When the estimated magnesium sulfate soundness loss is greater than the maximum magnesium sulfate soundness loss specified, the coarse aggregate source will not be allowed for use unless otherwise approved. The engineer will consult the geotechnical, soils, and aggregates branch of the construction division, and additional testing may be required before granting approval. Table 1. Coarse aggregate quality requirements. See table in specifications. 1. Used to estimate the magnesium sulfate soundness loss in accordance with section 342.2.1.1.2, microdeval abrasion. 2. Only applies to crushed gravel. 2.2 Bagus fines. Fines collected by the bagus or other dust collecting equipment may be reintroduced into the mixing drum. 2.3 Asphalt binder. Furnish the type and grade of binder specified on the plans that meets the requirements of item 300, asphalts, oils, and emulsions. 2.3.1 Performance graded, PG, binder. Provide an asphalt binder with a high temperature grade of PG 76 and low temperature grade as shown on the plans in accordance with section 300.2.10, performance graded binders, when PG binder is specified. 2.3.2 Asphalt rubber, AR, binder. Provide AR binder that meets the Type I or Type II requirements of section 300.2.9, asphalt rubber binders, when AR is specified unless otherwise shown on the plans. Use at least 15% by weight of crumb rubber modifier, CRM, that meets the grade B or grade C requirements of section 300.2.7, crumb rubber modifier, unless otherwise shown on the plans. Provide the engineer the AR binder blend design with the mix design, JMF1, submittal. Provide the engineer with documentation such as the bill of lading showing the quantity of CRM used in the project unless otherwise directed. 2.4 TAC code. Furnish CSS1H, SS1H, or a PG binder with a minimum high temperature grade of PG 58 for TAC code binder in accordance with item 300, asphalts, oils, and emulsions. Specialized or preferred TAC code materials may be allowed or required when shown on the plans. Do not dilute emulsified asphalts at the terminal, in the field, or at any other location before use. The engineer will obtain at least one sample of the tack coat binder per project in accordance with TEX 500C, Part 3, and test it to verify compliance with Item 300, asphalts, oils, and emulsions. The engineer will obtain the sample from the asphalt distributor immediately before use. 2.5 Additives. Use the type and rate of additive specified when shown on the plans. Additives that facilitate mixing, compaction, or improve the quality of the mixture are allowed when approved. Provide the engineer with documentation such as the bill of lading showing the quantity of additives used in the project unless otherwise directed. 2.5.1 Fibers. Provide cellulose or mineral fibers when PG binder is specified. Do not use fibers when AR binder is specified. Submit written certification to the engineer that the fibers proposed for use meet the requirements of DMS 9204, fiber additives for bituminous mixtures. Fibers may be pre-blended into the binder at the asphalt supply terminal unless otherwise shown on the plans. When at least 3% RAS is used in the mixture, the contractor may reduce the amount of fibers as specified in Table 4, Note 3. 2.5.2 Lime mineral filler. Add lime as mineral filler at a rate of 1% by weight of the total dry aggregate in accordance with Item 301, asphalt anti-stripping agents, unless otherwise shown on the plans or waived by the engineer based on Hamburg wheel test results. Do not add lime directly into the mixing drum of any plant where lime is removed through the exhaust stream unless the plant has a boghouse or dust collection system that reintroduces the lime into the drum. 2.5.3 Lime and liquid anti-stripping agent. When lime or a liquid anti-stripping agent is used, add in accordance with Item 301, asphalt anti-stripping agents. Do not add lime directly into the mixing drum of any plant where lime is removed through the exhaust stream unless the plant has a boghouse or dust collection system that reintroduces the lime into the drum. When the plans require lime to be added as an anti-stripping agent, lime added as mineral filler will count towards the total quantity of lime specified. 2.5.4 Warm mix asphalt, WMA. Warm mix asphalt, WMA, is defined as HMA that is produced within a target temperature discharge range of 215 degrees Fahrenheit and 275 degrees Fahrenheit using approved WMA additives or processes from the department's MPL. WMA is allowed for use on all projects and is required when shown on the plans. When WMA is required, the maximum placement or target discharge temperature for WMA will be set at a value below 275 degrees Fahrenheit. Department-approved WMA additives or processes may be used to facilitate mixing and compaction of HMA produced at target discharge temperatures above 275 degrees Fahrenheit, however, such mixtures will not be defined as WMA. 2.6 Recycled materials. Use of RAP and RAS is permitted unless otherwise shown on the plans. Do not exceed the maximum allowable percentages of RAP and RAS shown in Table 2. The allowable percentages shown in Table may second be decreased or increased when shown on the plans. Determine asphalt binder content and gradation of the RAP and RAS stockpiles for mixture design purposes in accordance with TEX 236F. The engineer may verify the asphalt binder content of the stockpiles at any time during production. Perform other tests on RAP and RAS when shown on the plans. Asphalt binder from RAP and RAS is designated as recycled asphalt binder. Calculate and ensure that the ratio of the recycled asphalt binder to total binder does not exceed the percentages shown in Table 2 during mixture design and HMA production when RAP or RAS is used. Use a separate cold feed bin for each stockpile of RAP and RAS during HMA production. 2.6.1 RAP. RAP is salvaged, milled, pulverized, broken, or crushed asphalt pavement. Crush or break RAP so that 100% of the particles pass the 2 inches sieve. Fractionated RAP is defined as 2 or more RAP stockpiles, divided into coarse and fine fractions. Use of contractor-owned wrap, including HMA plant waste, is permitted unless otherwise shown on the plans. Department-owned wrap stockpiles are available for the contractor's use when the stockpile locations are shown on the plans. If department-owned wrap is available for the contractor's use, the contractor may use contractor-owned fractionated wrap and replace it with an equal quantity of department-owned wrap. Unfractionated wrap is not allowed in PFC mixtures. Department-owned wrap generated through required work on the contract is available for the contractor's use when shown on the plans. Perform any necessary tests to ensure contractor or department-owned wrap is appropriate for use. The department will not perform any tests or assume any liability for the quality of the department-owned wrap unless otherwise shown on the plans. The contractor will retain ownership of wrap generated on the project when shown on the plans. The coarse wrap stockpile will contain only material retained by processing over a 3/8 inches or half an inch screen unless otherwise approved. Fine wrap is not allowed in PFC mixtures. The engineer may allow the contractor to use an alternate to the 3/8 inches or half an inch screen to fractionate the wrap. Do not use department or contractor-owned wrap contaminated with dirt or other objectionable materials. Do not intermingle contractor-owned wrap stockpiles with department-owned wrap stockpiles. Remove unused contractor-owned wrap material from the project site upon completion of the project. Return unused department-owned wrap to the designated stockpile location. 2.6.2 RAS. Use of post-manufactured RAS or post-consumer RAS, tear-offs, is permitted unless otherwise shown on the plans. RAS is defined as processed asphalt shingle material from manufacturing of asphalt roofing shingles or from re-roofing residential structures. Post-manufactured RAS is processed manufacturer's shingle scrap byproduct. Post-consumer RAS is processed shingle scrap removed from residential structures. Comply with all regulatory requirements stipulated for RAS by the TCEQ. RAS may be used separately or in conjunction with wrap. Process the RAS by ambient grinding or granulating such that 100% of the particles pass the 3/8 inches. Sieve when tested in accordance with Text 200F, Part I. Perform a sieve analysis on processed RAS material before extraction, or ignition, of the asphalt binder. Any stockpile that contains RAS will be considered a RAS stockpile and be limited to no more than 5% of the HMA mixture in accordance with Table 2. Certify compliance of the RAS with DMS 11000, evaluating and using non-hazardous recyclable materials guidelines. Treat RAS as an established non-hazardous recyclable material if it has not come into contact with any hazardous materials. Use RAS from shingle sources on the department's MPL. Remove substantially all materials before use that are not part of the shingle, such as wood, paper, metal, plastic, and felt paper. Determine the deleterious content of RAS material for mixture design purposes in accordance with Text 217F, Part 3. Do not use RAS if deleterious materials are more than 0.5% of the stockpiled RAS unless otherwise approved. Submit a sample for approval before submitting the mixture design. The department will perform the testing for deleterious material of RAS to determine specification compliance. Table 2. Maximum allowable amounts of recycled binder, wrap, and RAS. See table in specifications. 1. Combined recycled binder from fractionated wrap and RAS. 2. Unfractionated wrap is not allowed in PFC mixtures. May 3. Replace up to 5% fractionated wrap with RAS. May 4. Be used separately or as a replacement for no more than 5% of the allowable fractionated wrap. 3. Equipment. Provide required or necessary equipment in accordance with Item 320, Equipment for Asphalt Concrete Pavement. When AR binder is specified, equip the hot mix plant with an inline viscosity measuring device located between the blending unit and the mixing drum. Provide a means to calibrate the asphalt mass flow meter on site when a meter is used. 4. Construction. Produce, haul, place, and compact the specified paving mixture. In addition to tests required by the specification, contractors may perform other QC tests as deemed necessary. At any time during the project, the engineer may perform production and placement tests as deemed necessary in accordance with Item 5, Control of the Work. Schedule and participate in a mandatory pre-paving meeting with the engineer on or before the first day of paving unless otherwise shown on the plans. 4.1 Certification. Personnel certified by the department-approved hot mix asphalt certification program must conduct all mixture designs, sampling, and testing in accordance with Table 3. Supply the engineer with a list of certified personnel and copies of their current certificates before beginning production and when personnel changes are made. Provide a mixture design developed and signed by a Level 2 certified specialist. Provide Level 1A certified specialists at the plant during production operations. Provide Level 1B certified specialists to conduct placement tests. Table 3. Test methods, test responsibility, and minimum certification levels. See table in specifications. 1 Level 1A, 1B, and 2 are certification levels provided by the Hot Mix Asphalt Center Certification Program. 2 refer to Section 342.4.5, Production Operations, for exceptions to using an ignition oven. 3 Profiler and operator are required to be certified at the Texas A&M Transportation Institute facility when surface test type B is specified. 4.2 Reporting and responsibilities. Use department-provided templates to record and calculate all test data, including mixture design, production and placement tests, control charts, and thermal profiles. Obtain the current version of the templates at http://www.txdot.gov/inside-TxDOT/forms-consultants-forms-site-manager.html or from the engineer. The engineer and the contractor will provide any available test results to the other party when requested. The engineer and the contractor will immediately report to the other party any test result that requires suspension of production or placement or that fails to meet the specification requirements. Record and electronically submit all test results and pertinent information on department-provided templates. Subsequent sublots placed after test results are available to the contractor, which require suspension of operations, may be considered unauthorized work. Unauthorized work will be accepted or rejected at the discretion of the engineer in accordance with Article 5.3, Conformity with Plans, Specifications, and Special Provisions. Use the procedures described in Text 233F to plot the results of all production and placement testing, when directed. Update the control charts as soon as test results for each sublot become available. Make the control charts readily accessible at the field laboratory. The engineer may suspend production for failure to update control charts. 4.3 Quality Control Plan, QCP. Develop and follow the QCP in detail. Obtain approval for changes to the QCP made during the project. The engineer may suspend operations if the contractor fails to comply with the QCP. Submit a written QCP before the mandatory pre-paving meeting when directed. Receive approval of the QCP before beginning production. Include the following items in the QCP. 4.3.1 Project Personnel. For project personnel, include a list of individuals responsible for QC with authority to take corrective action. Current contact information for each individual listed, and current copies of certification documents for individuals performing specified QC functions. 4.3.2 Material Delivery and Storage. For material delivery and storage, include the sequence of material processing, delivery, and minimum quantities to assure continuous plant operations. Aggregate stockpiling procedures to avoid contamination and segregation. Frequency, type, and timing of aggregate stockpile testing to assure conformance of material requirements before mixture production, and Procedure for monitoring the quality and variability of asphalt binder. 4.3.3 Production. For production, include loader operation procedures to avoid contamination in cold bins. Procedures for calibrating and controlling cold feeds. Procedures to eliminate debris or oversized material. Procedures for adding and verifying rates of each applicable mixture component, example aggregate, asphalt binder, wrap, RAS, lime, liquid anti-strip, WMA, fibers. Procedures for reporting job control test results, and procedures to avoid segregation and drain down in the silo. 4.3.4 Loading and transporting. For loading and transporting, include type and application method for release agents, and truck loading procedures to avoid segregation. 4.3.5 Placement and compaction. For placement and compaction, include proposed agenda for mandatory pre-paving meeting, including date and location. Proposed paving plan, example paving widths, joint offsets, and lift thicknesses. Type and application method for release agents in the paver and unrollers, shovels, lutes, and other utensils. Procedures for the transfer of mixture into the paver, while avoiding segregation and preventing material spillage. Process to balance production, delivery, paving, and compaction to achieve continuous placement operations and good ride quality. Paver operations, example operation of wings, height of mixture in auger chamber, to avoid physical and thermal segregation and other surface irregularities, and procedures to construct quality longitudinal and transverse joints. 4.4 Mixture design. 4.4.1 Design requirements. Use the PFC design procedure provided in Text 204F, unless otherwise shown on the plans. Design the mixture to meet the requirements listed in Tables 1, 2, and 4. Use a superpave gyratory compactor, SGC, at 50 gyrations as the design number of gyrations, and design. The engineer will provide the mixture design when shown on the plans. The contractor may submit a new mixture design at any time during the project. The engineer will verify and approve all mixture designs, JMF1, before the contractor can begin production. Provide the engineer with a mixture design report using the department-provided template. Include the following items in the report: the combined aggregate gradation, source, specific gravity, and percent of each material used. Asphalt binder content and aggregate gradation of wrap and RAS stockpiles. Results of all applicable tests. The mixing and molding temperatures. The signature of the Level 2 person or persons that performed the design. The date the mixture design was performed, and a unique identification number for the mixture design. Table 4. Master gradation limits, percent passing by weight or volume, and laboratory mixture design properties. See table in specifications. 1. Defined as maximum sieve size. No tolerance allowed. 2. Mold test specimens to and design at the optimum asphalt binder content, JMF1. Perform the test for informational purposes only when no minimum number is specified. May 3 be decreased when approved. 4. The contractor may reduce the amount of fibers to no less than 0.1%, provided the mixture meets the drain down requirement, when at least 3% RAS is used in the mixture. 5. Unless otherwise shown on the plans or waived by the engineer based on Hamburg wheel results. 6. Used to establish baseline for comparison to production results. May be waived when approved. 4.4.2 Job Mix Formula Approval. The job mix formula, JMF, is the combined aggregate gradation, and design level, and target asphalt percentage used to establish target values for hot mix production. JMF1 is the original laboratory mixture design used to produce the trial batch. When WMA is used, JMF1 may be designed and submitted to the engineer without including the WMA additive. When WMA is used, Document the additive or process used and recommended rate on the JMF1 submittal. The engineer and the contractor will verify JMF1 based on plant-produced mixture from the trial batch unless otherwise approved. The engineer may accept an existing mixture design previously used on a department project and may waive the trial batch to verify JMF1. The department may require the contractor to reimburse the department for verification tests if more than 2 trial batches per design are required. 4.4.2.1 Contractor's Responsibilities. 4.4.2.1.1 Gyratory Compactor. Furnish an SGC calibrated in accordance with TEX 241F for molding production samples. Locate the SGC at the engineer's field laboratory and make the SGC available to the engineer for use in molding production samples. 4.4.2.1.2 Gyratory Compactor Correlation Factors. Use TEX 206F, Part 2, to perform a gyratory compactor correlation when the engineer uses a different SGC. Apply the correlation factor to all subsequent production test results. 4.4.2.1.3 Hamburg and Overlay Testing. Use an approved laboratory from the department's MPL to perform the Hamburg wheel test and provide results with the mixture design, or provide 10,000 G of the laboratory mixture and request that the department perform the Hamburg wheel test. Provide 25,000 G of the laboratory mixture and request that the department perform the overlay test. The engineer will be allowed 10 working days to provide the contractor with Hamburg wheel and overlay test results on the laboratory mixture design. 4.4.2.1.4 Submitting JMF1. Furnish a mix design report, JMF1, including Hamburg and overlay results. Provide representative samples of all component materials and request approval to produce the trial batch. 4.4.2.1.5 Supplying aggregates. Provide approximately 40 pounds of each aggregate stockpile unless otherwise directed. 4.4.2.1.6 Supplying asphalt. Provide at least 1 gal of the asphalt material and sufficient quantities of any additives proposed for use. 4.4.2.1.7 Ignition oven correction factors. Determine the aggregate and asphalt correction factors from the ignition oven in accordance with TEX 236F. Note that the asphalt content correction factor takes into account the % fibers in the mixture so that the fibers are excluded from the binder content determination. Provide the engineer with split samples of the mixtures before the trial batch production, including all additives, except water, and blank samples used to determine the correction factors for the ignition oven used for quality assurance, QA, testing during production. Correction factors established from a previously approved mixture design may be used for the current mixture design if the mixture design and ignition oven are the same as previously used unless otherwise directed. 4.4.2.1.8 Boil test. Perform the test and retain the tested sample from TEX 530C until completion of the project or as directed. Use this sample for comparison purposes during production. The engineer may waive the requirement for the boil test. Add lime or liquid anti-stripping agent, as directed, if signs of stripping exist. 4.4.2.1.9 Trial batch production. Provide a plant-produced trial batch upon receiving conditional approval of JMF1 and authorization to produce a trial batch including the WMA additive or process, if applicable, for verification testing of JMF1 and development of JMF2. Produce a trial batch mixture that meets the requirements in Table 2 and Table 5. The engineer may accept test results from recent production of the same mixture instead of a new trial batch. 4.4.2.1.10 Trial batch production equipment. Use only equipment and materials proposed for use on the project to produce the trial batch. Provide documentation to verify the calibration or accuracy of the asphalt mass flow meter to measure the binder content. Verify that asphalt mass flow meter meets the requirements of 0.4% accuracy, when required, in accordance with Item 520, weighing and measuring equipment. The engineer may require that the accuracy of the mass flow meter be verified based on quantities used. 4.4.2.1.11 Trial batch quantity. Produce enough quantity of the trial batch to ensure that the mixture meets the specification requirements. 4.4.2.1.12 Number of trial batches. Produce trial batches as necessary to obtain a mixture that meets the specification requirements. 4.4.2.1.13 Trial batch sampling. Obtain a representative sample of the trial batch and split it into 3 equal portions in accordance with Text 222F. Label these portions as contractor, engineer, and referee. Deliver samples to the appropriate laboratory as directed. 4.4.2.1.14 Trial batch testing. Test the trial batch to ensure the mixture produced using the proposed JMF1 meets the mixture requirements in Table 5. Provide the engineer with a copy of the trial batch test results. 4.4.2.1.15 Development of JMF2. Evaluate the trial batch test results, determine the target mixture proportions, and submit as JMF2 after the engineer grants full approval of JMF1 based on results from the trial batch. Verify that JMF2 meets the mixture requirements in Table 2. 4.4.2.1.16 Mixture production. Use JMF2 to produce Lot 1 after receiving approval for JMF2. 4.4.2.1.17 Development of JMF3. Evaluate the test results from Lot 1, determine the optimum mixture proportions, and submit as JMF3 for use in Lot 2. 4.4.2.1.18 JMF adjustments. If JMF adjustments are necessary to achieve the specified requirements, make the adjustments before beginning a new lot. The adjusted JMF must be provided to the engineer in writing before the start of a new lot. Be numbered in sequence to the previous JMF. Meet the mixture requirements in Table 2. Meet the master gradation and binder content limits shown in Table 4, and be within the operational tolerances of JMF2 listed in Table 5. 4.4.2.1.19 Requesting referee testing. Use referee testing, if needed, in accordance with Section 342.4.9.1, referee testing, to resolve testing differences with the engineer. Table 5. Testing frequency and mixture production tolerances. See table in specifications. 1 only applies to mixture produced for Lot 1 and higher. Aggregate gradation is not allowed to be outside the limits shown in Table 4. To ensure the binder content determination excludes fibers. Add the recycled binder content to the flow meter readout when the asphalt mass flow meter is used to determine binder content. May 3rd be obtained from asphalt mass flow meter readouts. 4 Binder content is not allowed to be outside the limits shown in Table 4. 5 The engineer may reduce or waive the sampling and testing requirements based on a satisfactory test history. 4.4.2.2 Engineer's responsibilities. 4.4.2.2.1 Gyratory compactor. The engineer will use a department SGC calibrated in accordance with Text 241F to mold samples for laboratory mixture design verification. For molding trial batch and production specimens, the engineer will use the contractor-provided SGC at the field laboratory or provide and use a department SGC at an alternate location. The engineer will make the contractor-provided SGC in the department field laboratory available to the contractor for molding verification samples. 4.4.2.2.2 Hamburg wheel and overlay testing. At the contractor's request, the department will perform the Hamburg wheel test on the laboratory mixture in accordance with Text 242F to verify compliance with the Hamburg wheel test requirement in Table 4. The department will perform the overlay test in accordance with Text 248F to verify compliance with the overlay test requirements in Table 4. The engineer will be allowed 10 working days to provide the contractor with Hamburg wheel and overlay test results on the laboratory mixture design. 4.4.2.2.3 Conditional approval of JMF1 and authorizing trial batch. The engineer will review the contractor's mix design report and verify specification conformance of the mixture and component materials. The engineer will grant conditional approval of JMF1 within 2 working days of receiving the complete mixture design report, JMF1, and all required materials. Unless waived, the engineer will determine the microdevol abrasion loss in accordance with Section 342.2.1.1.2, microdevol abrasion. If the engineer's test results are pending after 2 working days, conditional approval of JMF1 will still be granted within 2 working days of receiving JMF1. When the engineer's test results become available, they will be used for specification compliance. The contractor is authorized to produce a trial batch after the engineer grants conditional approval of JMF1. 4.4.2.2.4 Ignition oven correction factors. The engineer will use the split samples provided by the contractor to determine the aggregate and asphalt correction factors for the ignition oven used for QA testing during production in accordance with TEX 236F. The engineer will verify that the asphalt content correction factor takes into account the percent fibers in the mixture so that the fibers are excluded from the binder content determination. 4.4.2.2.5 Testing the trial batch. Within 1 full working day, the engineer will sample and test the trial batch to ensure that the mixture meets the requirements in Table 5. The engineer will have the option to perform the following tests on the trial batch. TEX 235F, to verify that drain down meets the requirements shown in Table 4. TEX 530C, to retain and use for comparison purposes during production, and TEX 245F, to verify the Cantabro loss meets the requirement shown in Table 4. 4.4.2.2.6 Full approval of JMF1. The engineer will grant full approval of JMF1 and authorize the contractor to proceed with developing JMF2 if the engineer's results for the trial batch meet the requirements in Table 5. The engineer will notify the contractor that an additional trial batch is required if the trial batch does not meet these requirements. 4.4.2.2.7 Approval of JMF2. The engineer will approve JMF2 within 1 working day if the mixture meets the requirements in Table 2 as well as the master grading limits and binder content shown in Table 4. 4.4.2.2.8 Approval of Lot 1 production. The engineer will authorize the contractor to proceed with Lot 1 production, using JMF2. 4.4.2.2.9 Approval of JMF3 and subsequent JMF changes. JMF3 and subsequent JMF changes are approved if they meet the mixture requirements shown in Table 2 and the master grading and binder content limits shown in Table 4, and are within the operational tolerances of JMF2 shown in Table 5. 4.4.2.2.10 Binder content adjustments. For JMF2 and above, the engineer may require the contractor to adjust the target binder content by no more than 0.3% from the current JMF. 4.5 Production operations. Perform a new trial batch when the plant or plant location is changed. Perform QC at the frequency and within the tolerances listed in Table 5. Take corrective action and receive approval to proceed after any production suspension for non-compliance to the specification. Submit a new mix design and perform a new trial batch when the asphalt binder content of any wrap stockpile used in the mix is more than 0.5% higher than the value shown on the mixture design report, or RAS stockpile used in the mix is more than 2% higher than the value shown on the mixture design report. At any time during production, the engineer may require the contractor to verify the following based on quantities used. Lime content, within plus or minus 0.1% of JMF, when PG binder is specified. Fiber content, within plus or minus 0.03% of JMF, when PG binder is specified, and CRM content, within plus or minus 1.5% of JMF, when AR binder is specified. Maintain the inline measuring device when AR binder is specified to verify the AR binder viscosity between 2500 and 4000 centipoise at 350 degrees Fahrenheit unless otherwise approved. Record AR binder viscosity at least once per hour and provide the engineer with a daily summary unless otherwise directed. If the aggregate mineralogy is such that TxDOT does not yield reliable results, the engineer may allow alternate methods for determining the asphalt content and aggregate gradation. The engineer will require the contractor to provide evidence that results from TxDOT are not reliable before permitting an alternate method unless otherwise allowed. Use the applicable test procedure as directed if an alternate test method is allowed. 4.5.1 Storage and heating of materials. Do not heat the asphalt binder above the temperatures specified in item 300, asphalts, oils, and emulsions, or outside the manufacturer's recommended values. Provide the engineer with daily records of asphalt binder and hot mix asphalt discharge temperatures, in legible and discernible increments, in accordance with item 320, equipment for asphalt concrete pavement, unless otherwise directed. Do not store mixture for a period long enough to affect the quality of the mixture, nor in any case longer than 12 HR unless otherwise approved. 4.5.2 Mixing and discharge of materials. Notify the engineer of the target discharge temperature and produce the mixture within 25 degrees Fahrenheit of the target. Monitor the temperature of the material in the truck before shipping to ensure that it does not exceed 350 degrees Fahrenheit, or 275 degrees Fahrenheit for WMA, and is not lower than 215 degrees Fahrenheit. The department will not pay for or allow placement of any mixture produced above 350 degrees Fahrenheit. Produce WMA within the target discharge temperature range of 215 degrees Fahrenheit and 275 degrees Fahrenheit when WMA is required. Take corrective action any time the discharge temperature of the WMA exceeds the target discharge range. The engineer may suspend production operations if the contractor's corrective action is not successful at controlling the production temperature within the target discharge range. Note that when WMA is produced, it may be necessary to adjust burners to ensure complete combustion such that no burner fuel residue remains in the mixture. Control the mixing time and temperature so that substantially all moisture is removed from the mixture before discharging from the plant. Determine the moisture content, if requested, by oven drying in accordance with Text 212F, Part 2, and verify that the mixture contains no more than 0.2% of moisture by weight. Obtain the sample immediately after discharging the mixture into the truck, and perform the test promptly. 4.6 Hauling operations. Clean all truck beds before use to ensure that mixture is not contaminated. Use a release agent, when necessary, shown on the department's MPL to coat the inside bed of the truck. Use equipment for hauling as defined in section 342.4.7.3.3, hauling equipment. Use other hauling equipment only when allowed. 4.7 Placement operations. Collect haul tickets from each load of mixture delivered to the project and provide the department's copy to the engineer approximately every hour or as directed. Use a handheld thermal camera or infrared thermometer, when a thermal imaging system is not used, to measure and record the internal temperature of the mixture as discharged from the truck or material transfer device, MTD, before or as the mix enters the paver and an approximate station number or GPS coordinates on each ticket. Calculate the daily yield and cumulative yield for the specified lift and provide to the engineer at the end of paving operations for each day unless otherwise directed. The engineer may suspend production if the contractor fails to produce and provide haul tickets and yield calculations by the end of paving operations for each day. Prepare the surface by removing raised pavement markers and objectionable materials such as moisture, dirt, sand, leaves, and other loose impediments from the surface before placing mixture. Remove vegetation from pavement edges. Place the mixture to meet the typical section requirements and produce a smooth, finished surface with a uniform appearance and texture. Offset longitudinal joints of successive courses of hot mix by at least 6 inches. Place mixture so that longitudinal joints on the surface course coincide with lane lines, or as directed. Ensure that all finished surfaces will drain properly. 4.7.1 Weather conditions. 4.7.1.1 When using a thermal imaging system, the contractor may pave any time the roadway is dry and the roadway surface temperature is at least 50 degrees Fahrenheit. However, the engineer may restrict the contractor from paving if the ambient temperature is likely to drop below 32 degrees Fahrenheit within 12 HR of paving. Provide output data from the thermal imaging system to demonstrate to the engineer that no recurring severe thermal segregation exists in accordance with Section 342.4.7.3.1.2, Thermal Imaging System. 4.7.1.2 When not using a thermal imaging system, place mixture when the roadway surface temperature is at or above 70 degrees Fahrenheit unless otherwise approved or as shown on the plans. Measure the roadway surface temperature with a handheld thermal camera or infrared thermometer. The engineer may allow mixture placement to begin before the roadway surface reaches the required temperature if conditions are such that the roadway surface will reach the required temperature within 2 HR of beginning placement operations. Place mixtures only when weather conditions and moisture conditions of the roadway surface are suitable as determined by the engineer. The engineer may restrict the contractor from paving if the ambient temperature is likely to drop below 32 degrees Fahrenheit within 12 HR of paving. 4.7.2 Tack coat. Clean the surface before placing the tack coat. The engineer will set the rate between 0.04 and 0.10 gal of residual asphalt per square yard of surface area. Apply a uniform tack coat at the specified rate unless otherwise directed. Apply the tack coat in a uniform manner to avoid streaks and other irregular patterns. Apply a thin, uniform tack coat to all contact surfaces of curbs, structures, and all joints. Allow adequate time for emulsion to break completely before placing any material. Prevent splattering of tack coat when placed adjacent to curb, gutter, and structures. Roll the tack coat with a pneumatic tire roller to remove streaks and other irregular patterns when directed. 4.7.3 Laydown operations. 4.7.3.1 Thermal profile. Use a handheld thermal camera or a thermal imaging system to obtain a continuous thermal profile in accordance with Text 244F. Thermal profiles are not applicable in areas described in Section 342.4.9.4. Miscellaneous areas. 4.7.3.1.1 Thermal segregation. 4.7.3.1.1.1 Moderate. Any areas that have a temperature differential greater than 25 degrees Fahrenheit, but not exceeding 50 degrees Fahrenheit, are deemed as having moderate thermal segregation. 4.7.3.1.1.2 Severe. Any areas that have a temperature differential greater than 50 degrees Fahrenheit are deemed as having severe thermal segregation. 4.7.3.1.2 Thermal imaging system. Review the output results when a thermal imaging system is used, and provide the automated report described in Text 244F to the engineer daily unless otherwise directed. Modify the paving process as necessary to eliminate any recurring, moderate or severe, thermal segregation identified by the thermal imaging system. The engineer may suspend paving operations if the contractor cannot successfully modify the paving process to eliminate recurring severe thermal segregation. Provide the engineer with electronic copies of all daily data files that can be used with the thermal imaging system software to generate temperature profile plots upon completion of the project or as requested by the engineer. 4.7.3.1.3 Thermal camera. Take immediate corrective action to eliminate recurring moderate thermal segregation when a handheld thermal camera is used. Provide the engineer with the thermal profile of every sublot within 1 working day of the completion of each lot. Report the results of each thermal profile in accordance with Section 342.4.2, Reporting and Responsibilities. The engineer will use a handheld thermal camera to obtain a thermal profile at least once per project. Suspend operations and take immediate corrective action to eliminate severe thermal segregation unless otherwise directed. Resume operations when the engineer determines that subsequent production will meet the requirements of this section. 4.7.3.2 Windrow Operations. Operate windrow pickup equipment so that when hot mix is placed in windrows, substantially all the mixture deposited on the roadbed is picked up and loaded into the paver. 4.7.3.3 Hauling equipment. Use belly dumps, live bottom, or end dump trucks to haul and transfer mixture. However, with exception of paving miscellaneous areas, end dump trucks are only allowed when used in conjunction with an MTD with remixing capability or when a thermal imaging system is used unless otherwise allowed. 4.7.3.4 Screed heaters. Turn off screed heaters to prevent overheating of the mat if the paver stops for more than 5 minutes. The engineer may evaluate the suspect area in accordance with Section 342.4.9.5, Recovered Asphalt Dynamic Shear Rheometer, DSR, if the screed heater remains on for more than 5 minutes while the paver is stopped. 4.8 Compaction. Roll the freshly placed PFC with a steel-wheeled roller, operated in static mode, to seat the mixture without excessive breakage of the aggregate and to provide a smooth surface and uniform texture. Do not use pneumatic rollers. Moisten the roller drums thoroughly with a soap and water solution to prevent adhesion. Use only water or an approved release agent on rollers, tamps, and other compaction equipment unless otherwise directed. The engineer may use or require the contractor to use TEX 246F to test and verify that the compacted mixture has adequate permeability. Adjust the mixture design or construction methods if the compacted mixture does not exhibit adequate permeability. Complete all compaction operations before the pavement temperature drops below 160 degrees Fahrenheit unless otherwise allowed. The engineer may allow compaction with a light finish roller operated in static mode for pavement temperatures below 160 degrees Fahrenheit. Allow the compacted pavement to cool to 160 degrees Fahrenheit or lower before opening to traffic unless otherwise directed. Sprinkle the finished mat with water or lime water, when directed, to expedite opening the roadway to traffic. 4.9 Acceptance Plan. Sample and test the hot mix on a lot and sublot basis. A production lot consists of 4 equal sublots. Lot 1 will be 2,000 tons. The engineer will select subsequent lot sizes based on the anticipated daily production. The lot size will be between 2,000 and 4,000 tons. The engineer may change the lot size before the contractor begins any lot. 4.9.1 Referee Testing. The construction division is the referee laboratory. The contractor may request referee testing if the differences between contractor and engineer test results exceed the operational tolerances shown in Table 5 and the differences cannot be resolved. The contractor may also request referee testing if the engineer's test results require suspension of production and the contractor's test results are within specification limits. Make the request within 5 working days after receiving test results and cores from the engineer. Referee tests will be performed only on the sublot in question and only for the particular tests in question. Allow 10 working days from the time the referee laboratory receives the samples for test results to be reported. The department may require the contractor to reimburse the department for referee tests if more than 3 referee tests per project are required and the engineer's test results are closer to the referee test results than the contractor's test results. 4.9.2 Asphalt Binder Sampling. Obtain a 1QT, 1 gal 4AR binder, sample of the asphalt binder for each lot of mixture produced. Obtain the sample at approximately the same time the mixture random sample is obtained. Sample from a port located immediately upstream from the mixing drum or pug mill in accordance with TEX 500C, Part 2. Label the can with the corresponding lot and sublot numbers and deliver the sample to the engineer. The engineer may also obtain independent samples. If obtaining an independent asphalt binder sample, the engineer will split a sample of the asphalt binder with the contractor. The engineer will test at least one asphalt binder sample per project to verify compliance with item 300, asphalts, oils, and emulsions. 4.9.3 Operational tolerances. Control the production process within the operational tolerances listed in Table 5. Suspend production and placement operations when production or placement test results exceed the tolerances listed in Table 5 unless otherwise allowed. When production is suspended, the engineer will allow production to resume when test results or other information indicates the next mixture produced will be within the operational tolerances. 4.9.4 Miscellaneous areas. Miscellaneous areas include areas that typically involve significant handwork or discontinuous paving operations such as driveways, mailbox turnouts, crossovers, gores, spot level up areas, and other similar areas. The specified layer thickness is based on the rate of 90 pounds/square yard for each inch of pavement unless another rate is shown on the plans. Miscellaneous areas are not subject to thermal profiles testing. 4.9.5 Recovered asphalt dynamic shear rheometer, DSR. The engineer may take production samples or cores from suspect areas of the project to determine recovered asphalt properties. Asphalt binders with an aging ratio greater than 3.5 do not meet the requirements for recovered asphalt properties and may be deemed defective when tested and evaluated by the construction division. The aging ratio is the DSR value of the extracted binder divided by the DSR value of the original unaged binder. Obtain DSR values in accordance with TxDOT T315 at the specified high temperature performance grade of the asphalt. The engineer may require removal and replacement of the defective material at the contractor's expense. The asphalt binder will be recovered for testing from production samples or cores in accordance with Text 211F. 4.9.6 Irregularities. Identify and correct irregularities, including segregation, rutting, raveling, flushing, fat spots, matte slippage, irregular color, irregular texture, roller marks, tears, gouges, streaks, uncoated aggregate particles, or broken aggregate particles. The engineer may also identify irregularities, and in such cases, the engineer will promptly notify the contractor. If the engineer determines that the irregularity will adversely affect pavement performance, the engineer may require the contractor to remove and replace, at the contractor's expense, areas of the pavement that contain irregularities and areas where the mixture does not bond to the existing pavement. If irregularities are detected, the engineer may require the contractor to immediately suspend operations or may allow the contractor to continue operations for no more than 1 day while the contractor is taking appropriate corrective action. 4.9.7 Ride quality. Measure ride quality in accordance with item 585, ride quality for pavement surfaces, unless otherwise shown on the plans. 5. Measurement. PFC will be measured by the ton of composite PFC. The composite PFC is defined as the asphalt, aggregate, and additives. The weights of asphalt and aggregate will be calculated based on the measured weight of PFC and the target percentage of asphalt and aggregate. Measure the weight on scales in accordance with item 520, weighing and measuring equipment. 5.1 Asphalt. The asphalt weight in tons will be determined from the total weight of PFC. Measured asphalt percentage will be obtained using Text 236F or asphalt mass flow meter readings for PG76 mixtures, as determined by the engineer. Measured asphalt percentage will be obtained using asphalt mass flow meter readings for AR mixtures. Provide the engineer with a daily summary of the asphalt mass flow meter readings for AR mixtures unless otherwise directed. Add the recycled binder content to the flow meter readings when calculating asphalt quantities. 5.1.1 Target percentage. The JMF target asphalt percentage will be used to calculate the weight of asphalt binder unless the measured asphalt binder percentage is more than 0.3 percentage points below the JMF target asphalt percentage or less than the minimum percentage specified in Table 4. Volumetric meter readings will be adjusted to 140 degrees Fahrenheit and converted to weight. 5.1.2 Measured percentage. The averaged measured asphalt percentage from each sublot will be used for payment for that lot's production when the measured percentage for any sublot is more than 0.3 percentage points below the JMF target asphalt percentage or less than the minimum percentage specified in Table 4. 5.2 Aggregate. The aggregate weight in tons will be determined from the total weight of PFC less the weight of the asphalt. 6. Payment. The work performed and materials furnished in accordance with this item and measured as provided under Article 342.5, measurement, will be paid for at the unit bid price for PFC, asphalt, of the binder specified and for PFC, aggregate, of the grade and sack specified. These prices are full compensation for surface preparation, materials including tack coat, placement, equipment, labor, tools, and incidentals. Trial batches will not be paid for unless they are included in pavement work approved by the department. Payment adjustment for ride quality will be determined in accordance with Item 585, ride quality for pavement surfaces.